And it's a series one, a sequence one. So what we've got here is, we've got some squares. Squares are written with a matchstick in the middle. So in the first figure number 1, we have 5 matches. And in the second one, we have these 5, and then we're adding 4 each time. So we have 9. Here we have those 9, and then we're adding another 4. So we're having 13, 17. In figure number 5, we've seen the pattern now, that what we're doing is we're adding 4 each time. So in figure number 5, we'd have 21 matches. So if we were to sketch up where we are with our picture number, which we're calling figure number n, figure 1, 5 sticks, figure 2, 9 sticks. Hugo is saying that this pattern can be represented by the formula 2 times n plus 5. Right, let's see if it works. Let's say n equals 1. So if Hugo's formula is correct, it should work for this, where we replace n with figure number 1. 2 times 1 plus 5 should give us the right number of sticks, but 2 plus 5 is 7. So he's wrong. We can already see that on his first question. Is there one that his formula does work for? Well, let's have a look for when n equals 2 then. Here we would get, with his formula, 2 times n, which is now 2, plus 5. 4 plus 5 does equal 9. So yeah, his formula does work for that one, but it's the only one it works for. It won't work in the next one either. 2 times 3 plus 5. 2 3s are 6, 6 plus 5 is 11. So it doesn't work for that one, and it doesn't work for this one. So his formula cannot be right. Okay? So we say, sorry Hugo, don't believe you. Off you go. Let's have a look at Julia then, because Julia's come up with a formula where she thinks that the formula should be 5 times n minus 2. So we test the formula for n equals 1. 5 times 1 minus 2. 5 minus 2 is 3. Does 3 equal 5? No. His formula can't work. When can it work? Well, we have to see. It obviously works for one of them. Let's test it for 5 times 2 minus 2. 10 minus 2 would give us 8. Does 8 equal 9? No. Let's try it again for 3. 5 times 3 minus 2. 5 3s are 15. 15 minus 2 equals 13. So yes, it does work, but only when n equals 3. So, sorry Julia, your formula doesn't work either. So how do we work out the formula? And the key to working out a formula is actually looking at the plus number here. The plus number that's down here is the number that should go in front of n. So the first thing we should do is we should say 4n, because we have a plus number of 4 down here. And then I think, okay, let me start then with n and say, okay, if n equals 1, the number of sticks should be 4 times 1. That would only give me 4, but I need 5 here. So how can I get 5? I can add 1 to my 4n and I'd get 5. So 4 times 1 plus 1. That would give me the number of sticks equals 5. Now I think that this is my formula. It works for one of them, but in order for it to be the correct formula, I have to check that it works for the other. So let's say now n equals 2. 4 times 2 is 8. 8 plus 1 is 9. 4 times 3 is 12. 12 plus 1 is 13. 4 times 3... 4 4s are 16. 16 plus 1 is 17. So my formula works for all of them. And this is the way to get the formula. You're looking at the plus number. Wow, that's the one that goes in front of n. Then you're saying, okay, how do I get from multiplying n by 4 to where I want to be? Sometimes it's by adding 1 or adding 2, or it could even be by subtracting 1 or by subtracting 2. Depends exactly how the sequence is built up. But when you use this system, it actually makes finding formulas very easy. So now I know that my number of sticks s can be represented by the formula 4n plus 1. So I'm happy that I've got the right formula now. That was part C. It says now, find then the number of sticks if n equals 100. Well, that's easy to do now, because s equals 4n plus 1, and n equals 100. So wherever I see the letter n, I replace it with the number 100. So the number of sticks will be 4 times n is 100 plus 1. It's going to be 401. So the number of matchsticks in figure number 100 would be exactly 401. What about if it asked me to go backwards then? It's now telling me in E that the number of sticks is 201. Well, I use my formula, that S equals 4n plus 1, and now I replace S with its real value, which is 201. So 201 equals 4n plus 1. What do I do to solve this? The first thing I want to do is I want n by itself. So my first step would always be subtracting. In this case, we want to get rid of that plus 1. How do we do that? Minus 1 to both sides. So we'd get 201 minus 1 equals 4n plus 1 minus 1. 1 minus 1 is 0, so we get 200 equals 4 lots of n. So 1 lot of n will be 200 divided by 4, which will give us 50. 4's into 20 go 5 times, and then the 0. So the figure number that will have exactly 201 matchsticks will be figure number 50. So this is the way that you approach this type of sequence series ones.